So we were discussing about the transportation problem in the yesterday's class, and we have discussed and we have formulated the transportation problem in the yesterday's class also by, and we have solved and I have told you that. So basically, if you want to solve a transportation problem, linear programming is little bit complex in nature. So we can go for alternate methods. So alternate methods will follow two steps. One is identifying a basic feasible solution, and next is to check whether the optimal solution is feasible or not. So to identify a basic feasible solution, we will have three methods: northwest corner rule, minimum or least cost method, and Vogel's approximation method. So if you are using northwest corner rule, so the solution, what you will get a solution, but it will not be a near, but it will never be a near optimum solution in the case of northwest corner rule. So if we employ this Vogel's approximation method, the solution whatever you are getting, it will make sometimes or in many cases we have seen that that will come near to the optimum. So to check the optimality, you have a stepping stone method and modified distribution method. So we will see what is methods. So we have formulated the transportation problem. So this is how, as I told you, this is how a typically a transportation model will look like. So the cost element and demand and supply will be known to you. So rest you have to calculate it. So let me draw a table and it will start solving a problem. Okay, so this is how a table will looks like. So here we will have, so it is something like from or to. So here you will have plants. So plants is A, B, C and D. Below you can write the demand, and this is warehouse. We'll have warehouse like P, Q, R and S. So this is capacity. So capacity is 34, 15, 12 and 19. Warehouse demand is 21, it is 25, it is 17 and it is 70. So the cost of transportation is 5, 1, 3, 3. Then you will have 3, 3, 5, 4, 6, 4, 4, 3, 4, 1, 4, 2. Okay, so this is how normally a problem matrix will looks like. Okay, so indicating that you have 4 plants A, B, C and D, and you have 4 warehouses P, Q, R, S. So the demand on warehouse is given. So P having a demand of 21, Q having a demand of 25, R is having a demand of 17 and S is having a demand of 17. The capacity of plant A is 34, B is 15, C is 12 and D is 19. So transporting one unit from plant A to P will cost 5 rupees. Transporting from plant A to Q, it will cost 1 rupee. Transporting from A to R, it will cost 3 rupee. Similarly, A to S will cost 3 rupee. So likewise, the cost matrix is given. So D to P is 4, D to Q is 1, D to R is 4, and D to S is 2. So this is how normally this is what will be the data will be given to you. Okay. Now, so this is how a model looks like. So this is called as the transportation matrix. Okay, so this is called as the transportation matrix. So whatever the problem is, so whatever the transportation model you are trying to solve, so always the first step is that you have to calculate your total demand and total capacity. Okay, you have to calculate total demand and capacity. Can someone tell me what will be the value here is?
80.
80. Both are 80?
Yes, sir.
Okay, so you can see both are 80. So step 1, irrespective of any model, you have to ensure demand equal supply. Okay, you are making a constraint. You have written here a constraint. All the constraints are of equality. So since it is of equality, you have to ensure here properly the demand is equal to supply. Okay, if the demand is not equal to supply, what will you do? If the demand is not equal to supply, what you have to do? You have to add a dummy row or dummy column. Okay, add either a dummy row or a dummy column, and whatever the unallocated capacity or demand is there, you have to provide it over there. Dummy row or column will have cost element equal to 0. Okay, dummy row or column will have cost element equal to 0. So whatever the excess value you are having, that you have to write it in the demand or capacity. So based on the row or column, whatever you are adding, accordingly you can add, and ensure always demand is equal to supply. Was that clear? Was that clear? So I will solve the problem by using northwest corner rule method. Okay. So I'll solve this by using northwest corner rule method. So I'll abbreviate it northwest corner rule. So northwest corner rule. So whatever your northwest corner is, okay, whatever your northwest corner is, you don't need to bother anything. You have to just give your assignment over there. So which is your northwest corner in the given matrix? So it will be AP. Okay. So the northwest corner will be AP. So what is the condition of AP? AP, the demand is 21 and capacity is 34. Am I right? The demand is 21 and capacity is 34. Okay. So how much can I allocate in this column? How much can I allocate in this column? I can allocate this 21 in this column. Okay, so I have allocated 21 in the column, the northwest corner column, that is A and P. So the demand for that particular column is completely met. So that column gets eliminated right now. Okay, now what will be the balance here after 34? What will be the balance here? What will be the balance here? Balance will be 13. Am I right? So 21 is allocated to AP. So now left out here will be 13, and this column, okay, this particular column, it has met. So it has eliminated from my problem now. Okay, now which is the next northwest corner now? Which is the next northwest corner now? The new northwest corner will be AQ. Okay, so AQ will be the northwest corner where the demand is 25, but the left out capacity is only 13. So what value can I allocate? What value can I allocate? I can allocate this 13 to this column over here. So 13 is allocated. So when the 13 is allocated, this is completely given and this value will become 0. Here the value will be balance will be 12 will be coming. So now either row or column which gets eliminated. The first row also will get eliminated from the problem. Okay. Now which is the new northwest corner? Which is the new northwest corner? The new northwest corner will be BQ. Okay, the new northwest corner will be BQ, and in the BQ you have a demand of 12 is left out and capacity is 15. So I will be allocating the balance 12 over here. Okay, the balance 12 is done over here. So this 12 also will turns to 0. Here balance 3 will come. Okay, now this particular column, okay, this particular column will get eliminated. Now the next new northwest corner will be BR. Okay, the new next corner will be BR. So in BR, the demand is 17, but only left out capacity is 3. So I will give that 3 over here. Okay, I'll give that 3 over here. So this 3 is also gone. That becomes 0. So 17, it will change into 17. It will, what will be the value? So it will be changed into 14. Okay, and you can see to that the second row also gets eliminated right now. Now 14 is the demand, but the capacity is 12. Now the new northwest corner will be CR. So here I will be providing that 12. Okay, so that 12 is completely met. Okay, so this particular row also will get eliminated. Balance here will be 2. So next, now new northwest corner will be DR. Okay, so DR it is 2 and capacity is 19. So that 2 is filled over here. So this particular column also got eliminated. Left out only will be DS. So DS, if you observe, you can see. So this also 2 has gone. It is 17 is left. So 17 is demand, 17 is capacity. I will allocate the 17 over here. So you can see all the values, all the demand and all the capacities are now allocated. Okay, all the demand and all the capacities right now is allocated. Okay, all the demand and all the capacities is allocated. So once again, so first identify the northwest corner. The first northwest corner is AP. So AP demand is 25 and capacity is 34. So the entire demand is met over here. So this column, first column gets eliminated. Balance is 13. Now the new northwest is AQ where the demand is 25 but left out capacity is 13. So I have provided the allocation of 13 over the balance is 12. So the demand and capacity for the first row, or if you see the capacity from plant A is completely over. So I removed that also from the problem. Demand of P is also met completely. So that has already got eliminated. Now the new northwest corner will be BQ. So BQ, the demand is 25, but you can see over here you have only a capacity. Okay, the demand is only 12 right now and the capacity is 15. So the demand of Q will be met from the balance demand will be met from the, so the second row will get, the second column will, the Q will gets eliminated, left out is 3. Now the new northwest corner will be BR. Here I have only capacity, left out capacity is 3, that is filled. Okay, so the capacity of B is also over, removed off. Now again further reduced. So here the C is having a capacity for 12, but you can see 14 is left out over here. So 12 I have allocated. Capacity of C is also completely over. Capacity of D is 19, which I given, left out 2 over here and 17 to S. So that's the way the complete allocation is given. Now you can calculate the transportation cost. Okay, you can calculate the transportation cost. Okay, how will you calculate the transportation cost? How will you calculate the transportation cost? Transportation cost will be 21 into 5 plus 13 into 1 plus 12 into 3 plus 3 into 5 plus 12 into 4 plus 2 into 4 plus 17 into 2. If I take the others all, there is no allocation. So that will be 0 into 3 plus 0 into 3. Okay. Again 0 into 3, 0 into 4. Likewise you can add, but that does not add any value. So I didn't taken that into account. So that is how we have calculated the transportation cost over here, X11 into C11. C11 is already given, X11 is the allocation, whatever we are providing. So only the allocated cell only I need to take into account. So that is only taken into account. The unallocated cell, the net value will be 0. So that I can avoid it. What will be the transportation cost? What will be the transportation cost? So when you calculate it, it will come as
259, sir.
Yeah, I think it is 257. You can just have a check. Okay. Okay. What lacks here? What basically lacks here? What basically lacks here?
Sir, we are just finding one solution, sir, but it might be the optimum or it might not be the optimum solution, sir. So it's
what
just
do you
one.
think? Do you think that this will be optimum?
No, sir, this is not optimum, sir.
Why?
Sir, because we are just randomly choosing some amount of products to be manufactured from one warehouse or the other, sir. We are not allocating based on the cost, sir.
Yeah, exactly. So the cost element is completely ignored in the northwest corner. Okay, the cost element is completely ignored in the northwest corner. You can see over here I have Q. Okay, where you can see the demand is there for, you can see over here the demand is there for 25 and capacity is 34, where the cost is only 1, where I am providing only 13 allocations over here. And you can see next the lowest cost in that is 3 and 3, but the amount is allocated, the quantity is allocated to the higher cost. So always the cost component is completely ignored in the northwest corner rule, and whatever the solution you are getting, it need not to be optimal. This can be it on the highest side. Okay. Is this clear? Is this clear?
Yes, sir.
Any doubts?
Sir, in the grid CR, sir.
Okay.
Sir, how you are actually getting 12, sir? Because if you are saying in the row before that, no, sir, that is row B. You told that out of 17, already three is there. Therefore, we are cancelling 17 and 14 is coming, sir.
Yes.
Then again, 12 plus 3, 15, it's already getting cancelled out. So this capacity 15 is also getting nullified.
Capacity?
15, sir. That is along
Yeah,
column B.
okay.
Again, actually, we are again cancelling this 14 and we are making 2 and here 12. I can't understand that step, sir. In the grid CR, could you explain that again, sir?
Yes. So first we have allocated this 21. Okay. Then the first column of P is eliminated. So from 34, if I subtract 21, 13 is left out. So the new northwest corner will be AR, where the demand is 25 and capacity is only 13. So I have allocated that 13 over here. Okay, and if you subtract from 25 that 13, you will get 12. Now the first row and first column got cancelled. Now the new northwest corner will be BQ. Okay, will be BQ, where you can see the demand is only 12 and capacity is 15. Okay, so the demand of 12 for Q is completely met right now. So the second column also gets eliminated. Balance capacity from plant B is 3. Okay, now the new northwest corner will be BR. So in the BR, you have a demand of 17, but left out capacity from plant B is only 3. So I have allocated that 3 over here. Capacity of plant B is fully utilized. I have removed the second row from my iteration. So if I subtract 3 over here, the balance demand of R will reduces to 14. Okay. Now the new northwest corner will be CR. CR is having a demand of 14, but plant C is only having capacity for 12. So I have allocated that 12 over here. Capacity of plant C is completely utilized. The row number C row is eliminated. Now left out row is D, and left out columns are R and S. So the total capacity for D is 19 and demand for R is only 2 and S is 17. So that 2 is given there and the rest 17 is given over here. So if you total it, so you can see the 21 over here. So 13 plus 12, it is 25. 3 plus 12 plus 2 will come as 17. This is directly 17 is given. This way, if you see 21 plus 13, it is 34. 12 plus 3 is 15. Then 12, directly 12 is given. 2 plus 17, 19 is allocated. Was that clarified your doubt?
Yes, sir.
Clear? Anyone having any doubt? Yes, please.
In the first column,
Your voice, I'm unable to hear you.
sir, in the first column,
Okay.
in the first column, you allocated 21 to the cost 5, right?
Yeah.
You can allocate it to the column B, the B, right? B, the row B.
See, this method is called northwest corner rule, where cost cost is ignored in this method. This gives an allocation only to the northwest corner. That's all.
Okay.
Okay, cost is not taken into account in this method at all. Only the particular position is alone taken into account.
Okay.
Right? Any other doubt? Okay, I'll solve the same problem by using least cost method. So again, the same problem. We have 4 plants A, B, C, D and warehouses PQRS. Cost of moving one item from plant A to warehouse B is 5. AQ is 1, AR is 3, AS is 3. Again, the same value we'll have PB is 3. Next is also 3. Next is 5. Next is 4. Next is 6. Next is 4. 4 and 3. You will have DP as 4. Then DQ as 1. DR as 4. DS as 2. So capacity here is 34. Here it is 15. Here it is 12. Here it is 19. And demand for P is 21. Demand of Q is 25. Demand of R is 17. Demand of S is also 17. Okay, so now I'll go with the method. It is least cost method or called as LCM method. Okay, now what is the lowest cost? Lowest cost in this matrix.
3. And capacity
Lowest
is
cost. Eh?
yes, lowest cost in the first
No. Among the entire matrix.
one.
So you can
Multiple
see one is there in AQ and one is in DQ. So always give preference for
maximum capacity.
first. No, always give preference for your first column. Go for second column. That's the way you can give the priority. Okay, so now we'll go for the first column itself. So AQ, okay, A is having a capacity of 34 and Q is having a demand of 25. So what is the status? The demand of 25 can be completely met over there. Am I right?
Yes, sir.
Yeah. So the allocation given over there will be 25. So I have allocated the 25 over there. Okay. So balance will be, so there will not be no 34 will be left out. Balance will be 9. Okay. And now it is, since the Q is completely, demand of Q is completely met. So that will be removed off from my iteration. So left out will be P, R and S. Now among P, R and S, which is the lowest cost? What is the
DS.
lowest cost?
2.
DS. DS is 2. Right. So DS, the demand at S is 17 and capacity is 19. So what allocation I can give?
You can give full, sir.
70.
I can give 17 over there. Okay, so when once the 17 is given, yeah, so I have allocated 17 over here. So the left out it will be 2. Left out value will be 2. So now the column S is also removed off. Am I right? Yeah.
Yes, sir.
So now left out will be P and R. Among P and R, which is the lowest cost?
PB.
3.
3.
3.
AR PB.
AR and BP. Yeah, right. So AR, if we see, so we'll go for the first, we'll go for the column wise. Sorry, we'll go for the row wise. The first row, there is a 3 is there. What is the status over there? A left out capacity is 9, having a demand of 17. So how much allocation I can give over here?
9.
How much allocation I can give?
9.
9.
9 I can give the allocation. So 9 when I give, this 9 turns to 0, and 17 minus 9 it will be 8 will be left out. So now if we see that row, that is row A also is completely moved off from the problem. Now what is left out? Left out is now what is the lowest cost?
4.
No.
3. 3.
Again,
3 is there.
BP.
BP it is 3 is there. So BP on 3, what is the condition? The capacity of plant B is 15 and demand is 21. So what's the status? So
All
how much
15.
allocation I can give?
15 you can give. 15.
I can give 15 over there. So balance will be 6.
0. 0. Oh, okay.
Yeah, here it will be 0. Row wise it is 0, column wise 6 is left out. Okay. Now which is the next? So from the uneliminated space, I have CP, so I have CP, DP, I have CR and DR. The lowest cost is
4 and you should take RS. RC. RC.
You can take RC, right? Correct. So RC, what the status is?
8 demand is needed.
8
8.
and capacity is 12.
12.
So how much
You
I
can
can
give the full
allocate? Yeah, I can allocate all 8 over there. So when I do that, the 12, the balance only will become 4. Okay, balance will become 4 now. So what gets eliminated from my problem?
R.
R column will get eliminated. Okay, so that is turned into 0. Okay, now what is left? Now what is left out?
6 demand from P.
Yeah, CP and CP and CD. Lowest cost is
D.
CP.
C.
Lowest is 4.
C
P,
lowest
D.
cost is DP. Okay, so 4 is the lowest cost. So DP, what is the capacity? Demand is 6 and
2
left out
capacity is
capacity is only 2. So I can give that 2 over there. Okay, and I give
4
2
in
over
CP.
there. The left out will be 4. So that also will get, that row also will get eliminated. Now left out only will be 4 is the demand and 4 is the capacity. So I can give it for C6. So C6 is 4. Okay. So the allocation is given. Now the allocation is complete. Okay. Now the allocation is complete. All demand and capacity is already met. Okay. So transportation cost. So transportation cost will be 25 into 1 plus 9 into 3 plus 15 into 3 plus 4 into 6 plus 8 into 4 plus 2 into 4 plus 17 into 2. Anything I left out?
$195, sir.
195. When comparing to the previous method, does the cost got reduced?
Yes, sir.
Okay, so we have considered the cost element over here. Okay, we have considered the cost element here. So when we are considering the cost element, you can see the cost is reducing from 257 to 195. Okay, to 195 by applying or by considering the cost least cost method.
The Northwest method is 259, sir.
Yeah, 259. 259. Okay, right. So from 259 to 195, the cost is being reduced. Any doubt?
Sir, one doubt, sir. Is this the lowest
Yes.
cost that is attainable, sir?
Which one?
Yeah, this one is 195 the lowest cost attainable.
May that when once you solve the optimality condition only, you will be able to know.
Okay.
Sometimes when you apply Vogel's approximation, may not be in this problem, some other problem, you may see that further cost reduction in the initial solutions will be possible. Now we will go and see what you mean by the term called as, or how to solve the, or how to find the initial basic solution using Vogel's approximation method. We solve the same problem. Okay, we have, this is the same problem what we have seen in the morning. So we have 4 plants A, B, C and D and 4 warehouses P, Q, R and S, and the cost of transporting 1 unit from plant A to warehouse P, similarly A to Q, A to R, A to S, etc. is given. Capacities of plant is given and demand of the warehouses is also given in the problem. So first step, as the first step of transportation, we have to see demand equals supply. So we have checked that if the demand is not equal to supply, add dummy row or dummy column, whatever is necessary to compensate demand equals supply. So okay, so in Vogel's approximation method, what you have to do in addition to our given problem, in red I have drawn one extra column and one extra row I have been added at the bottom. It is also a similar iterative procedure like least cost method, but here first what you have to do is that you have to find the row difference and you have to find the column difference. So row difference and column difference, you need to find it out. So the method whatever I am going to solve, that is called as Vogel's approximation method. In short, we will write it as VAM. Okay, so here we can find the row difference. Okay, you can calculate the row difference, and here you can calculate the column difference. Okay, so row difference, you can see the lowest cost is 1. Okay, this is the lowest cost, and after 1, the next lowest cost in the first row is 3. So the row difference is nothing but you are calculating among the two different, or the two lowest cost which are assigned in that particular row. So this will be 3 minus 1. So value will be 2. Next row, the lowest cost here is 3. Okay, the lowest cost here is 3. One more 3 is assigned over here. So the value will be 3 minus 3, that equals 0. Similarly, in the next also you can see 3 is there and 4 is there. So it will be 4 minus 3 equals 1. Similar in the next column 1 and 2. So it will be 2 minus 1 equals 1. Now see in the column wise. So column wise, so now see in the column wise. So column wise, here 3 and here 4. So it will be 4 minus 3, value will be 1. Next will be 1 minus 1 equals 0. Next will be 3 minus 4. Sorry. So 4 minus 3 equals 1. Next will be 2 minus 3 equals 1. Now we have calculated the difference among the row and column. Now go for largest row or column difference. Okay. So select largest row or column difference. Okay, so select largest row or column difference. What is it? What is the largest column difference here? Largest row or column difference lies for our
2.
Yeah,
1 and
2. Yeah, 2 lies for our first row. Okay. So if any type occurs, so tie breaking rule, so you have to can give the preference for row 1, row 2, row 3, row 4, then column 1, column 2, column 3 and column 4. That will be the order. Now the largest difference is 2. Now when you got a largest difference like that 2, now select, now the next step is to select the lowest cost. Okay. So once you find it, once you find the largest column or difference, the next step is select lowest cost. Okay, lowest cost cell. Now, which is the lowest cost cell in that first row? So this will be the lowest cost cell in the first row, 1. And you can give the allocation over there. So what is the demand at a warehouse Q? Demand at warehouse Q is 25 and plan A as a capacity of 34. Okay. So what will be the value? What allocation I can give here?
25.
Yeah, I can give the allocation of 25 over here. Okay, I can give the allocation of 25 over the, so balance will be this 34 will change into 9. Yeah. And what will get eliminated?
Q.
Q will get eliminated. Okay. When once the Q get eliminated, now what is left out? P, R and S. Okay. So you can make another table P, R and S. That will be A, B, C, D. You will have P, R and S. So the capacities will be, balance will be 9 here. It will be 15, 12 and 19. Here it will be 21, 17 and 17. And the cost will be 5 here, 3. This is also 3, 3, 5, 4, 6, 4, 3, 4, 4, 2. Okay, now again you need to add the column for calculating row difference and column difference. Now the lowest cost in the first row will be 3 minus 3. 3 minus 3, that will be 0. Next one, 4 minus 3, 1. Next one, 4 minus 3 again 1. Next one, 4 minus 2, 2. Here if we see 4 minus 3, 1. Again 4 minus 3, 1. Again 3 minus 2, 1. So largest difference. Largest difference again is row difference is high. Okay. So this is row difference. This is column difference. So it's 2. And what is the lowest cost? And which is the lowest cost? Lowest cost. Lowest cost is 2. Yeah. Okay. So you can see the demand and capacity if we see. Demand and capacity, what is the status? How much allocation I can give?
17.
Yeah. So I can give 17 allocation as 17 I can give. This 19 will change into 2. Okay. 19 will change into 2. Okay. So this is second iteration. Okay, second iteration. Now what happens? Column S will get terminated. Column S will get terminated. Now you can go for the iteration number 3. Okay. I'm not writing any column difference again because these 2 column only is left out. It remains as it is. So I'm not writing anything over there. So iteration number 3. So value will be 5 minus 3, right? 5 minus 3, 2. Again 5 minus 3, 2. So 6 minus 4, 1. And it is 4 minus 4, 0. Okay. So now which cell will I give the allocation? which cell will I give the allocation?
Sir, 6 minus 4, 2.
Yeah, okay, sorry.
D is the minimum, sir.
So 6 minus 4, 2. Okay, now which cell will I give the allocation?
Yeah.
First one, sir.
Pardon me?
AR.
A, sir.
AR. Okay, right. So give the preference for the first row. Lowest cost is 3, capacity is 9, demand is 17. Okay, so what can be given? 9 can be allocated over there. So once 9 is allocated, what is left out? Left out will be 8. So now what happens? Row A will get terminated. Okay, row A will get terminated. Go for next iteration. Go for the next iteration. Anyhow, this row difference is not going to change. Only column difference is going to change.
Sir, we'll take BD, sir. BD.
Pardon me, I didn't hear you.
BD, sir. BD. Will take.
BD. Wait a minute.
BP, BP.
BP. Okay, so what is the difference here? So 3, 4, 3. So again, it is 1. Here it is 4 minus 4, 0. This iteration number 4. Yeah, so again, if we see, so tie is here only. So we'll take the next row. Lowest cost is 3. So BP. What is the situation in BP? Demand is 21 and capacity is 15. So what allocation I can give? I can give the allocation of
15.
15. So I'll give the allocation here as 15. So 21 is gone. So only 6 will be left out. Pardon me. Hello.
Nothing, sir. Nothing. Continue.
Yeah. Okay. Right. So now, it is 6 minus 4, 2. And 4 minus 4, 0 remains over there. So here what happens? So again, yeah, so 6 minus 4, 2, iteration number 5, 2, and here it is again 0. So give the priority over here. Okay, lowest cost is 4, that is CR. Condition is demand is 8 and capacity is 12. So you can give that 8 over there. Okay, 8 over there. When once you give 8 over there, so that also will get terminated. Okay, and here the balance will be only 4. Okay, so now what is left out? 4 and 2, and here it is 6. So no further you can directly give 4 over here, and you can directly give 2 over here. Okay, so here I have given one column 25 into 1. So transportation cost equals 25 into 1 plus 9 into 3 plus 15 into 3 plus 4 into 6 plus 8 into 4 plus 2 into 4 plus 17 into 2. How much? What's the value?
195.
195. So when compared to the least cost method, I think there is no change has happened over here. There is no change has happened over here in this particular problem. But when compared to the northwest corner rule, what happened? From 259, the amount has changed into 195. Okay, so this is how the VAM iteration continues. I have tried to solve it from one table itself. If you feel that this is discomfort, every iteration you can draw the new tables and you can try to solve. So any doubts we will discuss? Any doubts or anything not clear we will discuss? Yes, please. Yes, please.
Sir, two methods we got 195, no, sir?
Yeah.
That means it is the lowest.
Which one?
The two methods we got 95.
No.
195, right?
No, we cannot say like that.
Okay, sir.
Okay. If we further try to solve it, you may see the difference. This will form the loops and will again change. See, you can see now this CPS6. Whereas there is a cost element of 3 is there, which I have not considered or ignored. Okay. And here if you see there is a cost element 3 is there. There is an element of 2 here, which I have not considered. Okay. So again, sometimes this will form the loops and again iterations may require to check or to get the optimal solution. We'll quickly go through the PowerPoint. So the three methods we have discussed for basic feasible solution. Yeah, so basic feasible solution conditions to be satisfied. Only a single type of commodity is being shipped from an origin to a destination. Total supply equal to demand. We have formulated the constraints also. So AI is a supply and Bj is a demand. So AI equals Bj. All are positive integers. The allocations are independent, do not form a loop. They are exactly m plus n minus 1 allocation. This part I'll come to it while solving the optimality. If this is not satisfying, we call normally it as a degenerate problem. M is number of columns, n is number of rows. So number of rows plus number of columns minus 1, that much allocation should be there in a problem. Otherwise the problem is called degenerate. So degeneracy may come. There are methods to overcome degeneracy is also explained in the transportation problem that we will discuss in the coming classes. Okay, so I think we have already discussed the method. Yeah, now just read the problem and get me the solution by applying northwest corner rule. You can read the question and get me the solution. Where will be the first allocation will be given by using northwest corner rule?
P1 R1.
Yeah, so P1 R1, what value will be given?
20.
20. Okay. So that is completely over. Now, which is the next northwest corner?
Sir, P2 R2.
P1 R2. P1 R2.
P1 R2. Correct. P1 R2. Okay. So P1 R2, rest 20 is given. Yeah. Now, which is the next northwest corner?
P1 R3.
P1
P1 R3.
R3. Yeah. Okay. So P1 R3. Okay. So that 10 will be given. Balance will be 40. What will be the next northwest corner? After P2 R3. P2 R3, if we are providing, what value will you provide?
40.
40. Okay. So balance will be there. Then
P2 R4.
then P2 R4. Okay. Yeah. So that's the way you can proceed. So you'll get the allocations like this. You can see the allocations. So total cost is the total cost. So 3 into 20 plus 5 into 20 plus 7 into 10 plus 8 into 40 plus 2 into 35 plus 2 into 25. So if you solve it, I think you will get the value as 670, right?
Yes, sir.
Yes, sir.
So minimum cost method, you take the same problem. Where will give the first allocation?
2 1.
First allocation will give it 2 1. Okay. So 20 is met. That's over. Next allocation.
2 4.
Okay. Next allocation.
2 3. Sorry, 3 4, sir.
Next allocation 3
3
4.
4.
Okay. Then
2 2 or 1 2.
pardon me.
2 2 or 1 2, sir.
2.
2 2 or 1 2. Both are 5.
Which one will you give?
1 2 1 2.
1 2. Okay. Right. Correct. 1 2. Then what will be left out?
2 2.
Yeah. So that's 2 2. So 20. Then 2 2. No. 2 2 is already no 2 2. Already 55 plus
Okay, okay.
20
Yes, sir. Yes.
75
Yeah.
is gone. So 2 2 doesn't exist. Okay. So 1 2 you can provide.
1 4, sir.
That's the way you can proceed. You see, not 1 4.
1 3.
1 3. Okay. So this is why you have to solve it. When you are solving it, please remove the rows and columns. Redraw it again one more time and then try to solve. Then it will be easy. Okay. So the cost is coming as 650. What was the previous cost? 670. From 670 it changed into 650 when we have gone for least cost method. Any doubt in any of these allocations?
No, sir.
Okay. Then the next method is Vogel's approximation method. Yeah, the same problem. No, it's not the same problem. It's a different problem is given. Yeah. Please calculate and please let me know. What will give the first allocation and what will be the value? Where we will give?
1 4, sir. 1 4.
1 4. Why?
17 minus 4. 17 minus 4
No,
will
sir.
be the
9
highest
minus
value.
7. 9 minus 7. In the second row. 2, sir. It will be minimum.
So here if you subtract, the value will be values are in the down. So this is 13. The next is 2. Okay.
5.
Next is 5. Here it will be 4. Here it will be
15.
15.
8.
Here it will be
8.
8.
3.
Here it will be 3. Okay. So which one?
Second row, sir.
Second row. Why?
Minimum thing.
Minimum of what?
Column.
Eh?
Second column.
Second column,
Second
sorry.
column. Okay.
Yeah.
Largest difference.
Yeah.
Okay. Largest difference in that minimum cost. Okay. Largest difference in that minimum cost. So first allocation you can provide over here in this. So 1, 2. So 1, 2, you can see it is 40 is the demand, 120 is
13.
the supply. Okay. So you can provide that allocation 40 over there. This 120 will reduce to 90. Any doubts?
No, sir. No, sir.
Okay. So okay. So now that 40, yeah, so that 40, so that gets removed off. Go for the next iteration. So that is over. So what will be the next difference? So this this row, sorry, this column got completely eliminated. Now what happens? The next step. So 17 minus 4, 13. 9 minus 7, 2. Then 20 minus 15 as 5. Then
Third column.
60 minus
so
30.
24 minus 20 as 4. This is 9 minus 17. Sorry, 17 minus 9. And this is 7 minus 4. So the largest difference is
8.
the
13.
largest
13. Sorry,
difference is
13.
13. And the lowest
1,
cost
4.
in that is
4.
4. So 4, you have a demand of 110 and supply is 80. So that 80 you can provide over there. This 110 will get 110, balance will be only 30. So first row also will get eliminated. Okay. Now next step.
Column 3, sir.
Sir.
Column
3.
3.
Largest difference 8. Yeah.
Largest difference is 8. Correct. Okay. And
That minimum is
value
9.
minimum is 9. So 30 and 70. So 30 can be given. So balance will be 40. So column 3 also got eliminated. Now column 1 and 4. Yeah, column 1 and 4 is left out. You can again calculate the difference.
Row 3. Okay, sorry.
You can again calculate the difference. So 24 and 7, 32 and 15, 60 and 30. So same way 32 and 24. Then you will have 15 and 7. So you can subtract it. Okay, so 17, 17, 8 and 8. So you can complete it. Okay, so the basic feasible solution will come to a value of 3520. So these are the penalties which is given for the various iteration. Okay, that is shown over here. You'll get the value as 3520 if you compute the calculations. Yeah, so